Welcome back to the course on engineering metrology. Dr. Ramkumar has already covered maximum part of this course, and we have discussed what is metrology, what is the use of metrology in daily life, use of metrology in manufacturing, in mechanical measurements, and what we did when we are just going through the previous lectures. We were looking at the various instruments, various kinds of measurements that we obtain from different kinds of sources, and we also saw what are the sources of errors, and you might have been now known that the errors are the main thing which we were dealing with. The errors are to be reduced. If the errors are minimum, our readings are very close to the original value, to the true value. So accuracy and precision. So in this module, I will discuss statistics in metrology. Statistics is an inherent part of metrology nowadays, because you know the errors can be at both ends. Error is one of the technical terms that we have been using till now. So I am going to talk about statistics here. In statistics, the term error is more known as uncertainty. So what happens when we take measurements? There might be errors because of certain sources, certain reasons. Maybe the instrument is not working well, the experimenter is not working well, there are systematic errors, there are random errors, and the thing is that we generated data through metrological experiments, and when the data is generated, some information is to be extracted or obtained from this data that we have to present finally. Okay, this is our final reading, or this is our final measurement based on which we need to manufacture. For that, the data that is generated sometimes is very big. No, if not very big, let me say if there are 20 observations that we have taken, we just take the average of that. So 20 observation is just one of these samples that we have taken from, and the overall, let me say in a manufacturing concern, that might be manufacturing thousands of components, and we have picked one sample in one sample of 20 observations of 20 units out of 1000, let me say. So those 20 units, the measurements are taken, and that is going to represent the whole population. So that is why statistics comes into play. The role of statistics, I will go through these contents in the lecture. Use of statistics in metrology, that we will discuss. Then certain definitions like measurement, measurand. I also discuss precision and accuracy, the statistical viewpoint of that. Then type A and type B uncertainties. Uncertainties is equivalent to error that we discussed before. Then what is probability? Probability, you people know that what is probability. Probability is a chance of occurrence. But the use of probability, there are certain concepts or certain techniques which are devised from the probability. Probability density function, cumulative density function, probability distributions, and how these distributions are used to conduct or to find out that whether the sample represents the whole population or not. So these things we will discuss. So this is just an introductory lecture to certain statistical concepts. So statistical science and physical metrology are inseparably knotted. What I mean to say is that metrologists have long understood this, that statistics cannot be separated from the physical methodology, because certain statistical methodologies and models are developed which are useful, which have been useful in past, and certain other models are being developed in future also, which are useful to generate the knowledge from the data that we have obtained from metrological measurements. So measurement quality affects what can be learned from the data collected and processed using statistical methods, and appropriate data collection and analysis quantifies the quality of physical measurements. So I could say number 1 and number 2. Measurement quality, if the errors are there in measurements, the measurement quality would be low. Measurement quality affects the data. The data that is obtained through measurements is not very reliable. I'll discuss about reliability and validation. Data could be valid or data could be reliable. It could be both. It cannot be both. So data has to be valid and reliable. So if the data is sometimes the data is not valid but reliable, we'll see this in context of accuracy and precision as well in the forthcoming slides here. So what happens? Measurement, that is metrology, affects what kind of data is collected, and appropriate data collection and analysis quantifies the quality of physical measurements. This is done by the point 2 is done by statistics. So our purpose in this course is to provide a unified overview of interaction between statistics and physical measurements with the people who have the prerequisite, people who have completed at least 2 semesters of their engineering or with roughly first year graduate level background in statistics. Okay, some background in statistics like or I can discuss that as well, what is mean, what is median, what is mode, all those things most of you might be knowing, but I'll just give an overview of that as well. So in this lecture we are going to discuss the role of statistics in metrology or in measurements. So some statisticians, notably those who are working in standards organizations such as national and industrial laboratories, and in quality assurance and statistical organizations in manufacturing concerns, have contributed to good measurement practice through development of statistical methodologies which are useful to quantify the measurement quality, and sometimes measurements are conducted using some complicated instruments as well, and those instruments are those calibrated properly or not. So in calibration also statistics play a role. A calibration curve has to be plotted, that is statistics. So what is statistics? Statistics is the study of how best to, number 1, collect the data. What is the way to collect data? From where is the data obtained? Is the data obtained from the primary source, or is the data obtained from some handbook? The data can be of 2 types here. The data can be primary or secondary. In this course, whatever we have been studying till now was the primary data. The data that we generated was the primary data, and data was all collected taking the actual measurements using some instruments and measuring some workpieces, and we measured angular, linear, screw thread, gear metrology. We went through all those things. That was all primary data. Primary data where the data is generated by the experimenter, that is primary data. Sometimes the data is not generated at the first place, however, it is taken from somewhere when it is recorded previously. So the past data that we are using, the data for instance, those are available in the handbooks, those are secondary data. I can even take it into this context that, okay, we know the kind of standards, the primary standards, secondary standards, tertiary standards, and working standards. You know the working standards, those we are using in the industry or in our laboratories, those are compared with the tertiary standards or national standards, and those might be compared with the secondary standards or primary standards. So those kind of data with which the comparison is made is kind of secondary data, and the data that we generate is kind of primary data. When you know that okay, an instrument is, when you purchase an instrument, you purchase a vernier caliper, you know that the least count is 0.02 mm, and this is the secondary data, that the least count is 0.02 mm, that is the value that is given. The data that you generate, that you actual least count that you find out, is the primary data. Okay, so we can detail it further when we'll come through actual examples here. So next step is to summarize or describe the data. To summarize and describe the data, we have collected many observations. We have seen that the error that is obtained, error might be linear, might be quadratic, various kinds of error forms where error curves might be there. So we need to summarize what kind of data have we generated, and the thing is that from the data, information has to be extracted. Summarization means, for instance, mean, mode, median, standard deviation, variance is kind of summarization of data, or is kind of describing the data. So average would be, for instance, is for instance, if you are taking some readings using a voltmeter and the reading has to be 5 volt all the times, and the readings that you are observing, the true value is 5 volt, and reading that you are observing is 5.1, 5.2, 5.3, 4.9, 4.8, so on, and the average comes out to be 5.1. So this average data tells that the overall you are 0.1 volt forward, or 0.1 volt more than the true value. So this is actually describing the data. So then we draw the conclusions or inferences based on data. Actually, these days, a very prominent subject which people are studying is analytics. Analytics is dealing with the data, dealing with big data, people having so many customers are there, so many products are there, there are work in progress inventory, there are the various inspection that happens within factory, during raw material, during delivery, all those things. There's so much of data available in the industry. So analytics is there. So I think I can even divide these 3 steps into the 3 major concepts of analytics. So this is collect data, is predictive analytics. Predictive analytics is you predict sometimes you predict, or sometimes you just collect the data and you just record the data. That is a kind of predictive analytics. Other 2 parts are descriptive analytics and prescriptive analytics. Descriptive analytics is when you describe the data, you use some statistic, not statistics. Statistics is the science, is the study. Statistic is the variable on which you are working, like mean is one statistic, standard deviation is one statistic. I am using a word statistic here. This is mean is represented by mu, median is represented, standard deviation is represented by sigma. So we summarize this using descriptive analytics, and we draw the conclusion using prescriptive. By prescriptive analytics means we give some prescription, some results, some conclusion that the data that we have generated, we have worked on that, we have analyzed it, we have tried to plot it, and we have tried to generate a curve, maybe probability density curve that we will discuss, and we have found that the data is significant or not significant. These might be new terms for some of you. I will definitely explain what is significant and what is not significant data. And for that we will discuss normal distribution curve. So please bear with me, we will discuss this in the next lecture. So this is all a framework which recognize their reality and omnipresence of variation in physical processes. So next, I like to discuss a few terms: measurand and measurement. Measurement is the one thing which we have been listening, which we have been going through from the very beginning. So what is measurand? Measurand is a physical quantity whose value of x is of interest, and for which some well-defined set of physical steps produce a measurement. Why? A number that intended to represent a measurand. Measurand is actually the original value which we are trying to find, and measurements are the value which through experiments we are obtaining, we are getting the values. And actually the measurement has to be equal to the measurand ideally, but there is a difference. This difference is known as error. So we need to see what is the behavior of the error. Is the error linear? Linear means is it varying in a linear way? Is it continuously increasing or continuously decreasing, or is it constant, or is it non-linear? We'll see these things. So measurement is a well-defined set of physical steps that produce some value. So measurement is the act of experimentally determining a physical quantity using specialized equipment. So it uses some, I liked certain characteristics of measurements here. Just to recall, however, we have discussed measurement before. Measurement in metrology can be only about the physical quantities. Physical quantities only. However, when we talk about statistics, the measurement can include sociological, psychological, and many other social and aspects but in metrology we are only interested in the physical quantity. Physical quantity not only means the quantity that we can hold. Physical quantity might be temperature, might be the flow of wind. So any quantity that we measure using some specialized equipment, that is measurement. So I will write it using some equipment. So I am using the word equipment here. We can use the word tools or instruments. However, the words tool or instrument or source, sometimes they might be for the interview or for the social studies. These are because we are talking about statistics. The tool can be questionnaire, there can be telephonic interview. These can also be called as instruments. So it is better to use word equipment. If I use the word instrument here as well, the instrument would be the instrument, one of the instruments that we have studied before, or the tool that we have studied before in this course only. So it is about the physical quantities. So measurement is the experimental estimation of parameters. So it is experimental estimation. So it always involves experimentation, like in laboratory demonstrations that we saw that we had to first prepare, we have to first tool and the workpiece which is to be measured, the workpiece or the measurand, that the value that we need to know, and the tool also has to be prepared. There are the ways to handle the tool. There are specific ways. We have to be careful. We have to be aware of the precautions that we need to use. We have to see that the error that doesn't come. Those are the experimenter's error or experimental error. The experimenter error is the experimenter. For instance, I am the experimenter. I am not taking the readings carefully. It might be my error. Experimental errors might be the experiment is not conducted properly. So, because measurement is an experimental estimation, as I have put here, it is important to prepare the equipment. So, it is an estimation. So, estimation involves the calculation, the statistical assessment of product quality indicators and other similar procedures. So, next point is measurement is performed using special technical equipment which may be scales, measuring instruments. This definition, general definition of measurement does not include other determination methods that do not use technical devices. For instance, sometimes the expert assessment is there. An expert can say, okay, this is, I think this is about 1 feet. But when we are talking about measurements, we are talking about the quantitative data. Mostly we are dealing with quantitative data, it might be qualitative as well. So, in that case, there has to be some equipment. So, next point here is measurement determines a value. This was actually the basic definition, steps to produce a measurement y. This value y has to be determined using measurements. So, it might be the comparison of a quantity against the unit or scale for that quantity. So, there can be certain criteria. So, I would rather put these 3 major characteristics of measurement. Next is measurement error. Measurement error, we have discussed this before multiple times. The difference between the actual measurement and the observed measurement is known as measurement error. So, what do you think? What kind of error is this? This is a parallax error. This is the number one. If I classify it, this is the error from the observer. This is the observer's error. So, the observer is looking from different angles. This observer is reading it as 4.9. This is exactly perpendicular to the scale. He is reading 4.8, which is the actual reading. So, this is 4.7, 4.8, 4.9. So, this is the actual observation, at least what is represented by this scale. So, because of the different angles of viewing, angle 1 and angle 2, we are not getting the actual value. This is the measurement, one of the measurement errors. So, trying to explain the measurement further, measurement, okay, I can classify, measurement classification. Measurement can be classified based upon the trait of accuracy, measurement of equal accuracy or measurement of unequal accuracy. Based upon accuracy, that can be equal versus unequal accuracy. So, measurement of equal accuracy means a series of measurements of some quantity performed using measuring instrument of identical accuracy under identical conditions, and unequal accuracy would mean the measurement of some quantity which gives different accuracy under different conditions. So, identical accuracy under identical conditions, whenever we measured from this point, it has to be all the time, because it is the identical way. Always if it is at this angle from the original, it will always give 4.9. So, this is called measurement of equal accuracy. Sometimes at different accuracies, at different conditions, the measurement values have different accuracies. So the method used for reduction of measurement of equal accuracy and measurement of unequal accuracy are slightly different. Thus, prior to reducing a series of measurement, a check needs to be performed to determine whether or not measurement are of equal accuracy. So this is generally used using the F-test or goodness of fit test, chi-square test that we might discuss. So in terms of number of measurements, the measurements can also be classified. So it is single versus multiple. Single measurement is a measurement that is performed only once. Multiple measurement is a measurement of the same quantity in which the result is obtained from several single measurements in a succession. So these are called replicates. So there are various ways to classify measurement. Another way may be the measurement based upon the technical measurement and metrological measurement. So the technical measurements are intended to obtain information on the properties of physical objects, processes and phenomena in the surrounding world, and metrological measurements are the measurements which we are studying in this course, and that ensure metrological traceability and required accuracy of technical measurements. So another base is relative or absolute. There are certain ways we can say technical versus metrological. Actually, metrological measurement supports the technical measurement. It's to see that if are the technical measurements repeatable or not, reproducible or not. So then is absolute. We have discussed this. Absolute versus relative. This you know, the absolute, in absolute measurement we have an exact zero, and in relative measurement the ratio of some quantity is taken. So there are various other ways. Next we can discuss something here about how the theory of measurement is devised. Theory of measurement, or I can better put it here, theory of measurement accuracy. So what we have originally, we have a true value. True value is the one that is desired, that we need to be close to, or we need to equal to if possible. So true value is the value, those are the standards which are maybe primary standards or maybe secondary standards, but the true value that we have in the working, in the actual industrial environment or in the actual laboratory environment, we have some true value, some value that is not exactly true value, but that is acceptable. So that is the conventional true value, based on which actually we are not working on this. We are not actually working using true value, we are working using an instrument that can give us, or that can measure the closest up to the conventional true value. So then we have, based upon the conventional true value, we have, if I use some equipment here or some instrument here or some tool here to measure something, I will get a measurement result. So what we have obtained? We have obtained a result. Like I said, a voltmeter, that was, the true value was actually 5. Conventional true value could be, if I take up to 2 places of decimal, conventional true value may be 5.05 or 4.95. This is the acceptable, okay, in conventional true value, 4.95 to 5.05. 0.05 volts. Okay, the true value I could say here is 5 volt. This is 4.95 is less than equal to conventional true value is less than equal to 5.05 volt and volt. Then measurement result is something that we obtain. Let me say the value I have got here is 4.9. This measurement result, however I worked on this thing, this measurement result has two things now. It has the value, original value, the true value plus error. So from here we will get the error. Here error I can say is 0.1 volt, that is the difference from 5 volt. So this, here we get the measurement error. Now we need to work on the measurement errors. We need to see that the errors that we are getting here, are these errors high enough so that we can reject the measurement that we have taken. We can say that the measurement or the instrument is not working properly, or there is some error on the part of experimenter, observer, instrument, because of which we are going to reject the overall experimentation that we have done. Or is it significant, or we can accept that as well based on certain criteria. So what we do here, we use certain statistical tools or certain statistical methods to find the interdeterminacy of measurement result. So this is based upon the error. The error that we have obtained here, is used here, based upon this error, used here to find the interdeterminacy. This was just an introduction to what statistics can do. So what, where the statistical theory can be applied to obtain some information out of the data that we have obtained from the experimentation. I'll just take a break here. In the next part of the same lecture, I'll discuss this concept further. So this first lecture would be just an introduction. In the second part of lectures, in the second lecture on statistics, we'll discuss about uncertainties. We'll discuss about the parameters or the statistics which are used in determining the various in this interdeterminacy of measurement result, and we'll discuss about probability distributions and how the probability distributions can be used. Not only this will be the first section of our statistical concepts in metrology. In the second section, we will also discuss this sampling. What is the sample number that is to be taken? Then quality control. So what is the way, or when we can say that the quality is within control, or what is the way to control the quality? Quality assurance. Quality assurance is that how the quality control procedures are implemented, how well are they implemented. So we'll discuss all these things, and acceptance sampling as well, we'll discuss these things. So let us meet in the next part of this lecture. Thank you.